think is what most of you are probably busy with at the moment at school. So we'll move on to that next. A couple of things that we still need to cover though. Today's lesson is on sum to infinity, and then the last lesson or normal lesson on Thursday is going to be on exam questions, and then we're also going to look at some slightly more difficult exam questions in the second session on Thursday. So if you are available and you can join us, then please do. But as far as today is concerned, we're going to talk about sum to infinity. Okay, so first of all, what does the word infinity mean? What if we call something infinite, what are we saying? What does that mean first? Does anybody know?
It never ends, ma'am.
It never ends. Okay, so Michelle, what were you going to say? You also raised your hand. Okay, so Talia said it doesn't end quite right. Okay, and then we get two different types of sums to infinity. We only study one in matric. So I just want to explain the difference before we carry on between the words convergent and the words divergent. Okay, so if something converges, all right, it means that it all sort of comes to the same point. Okay, so it converges like so. But if something is diverging, then it's doing this. So it's going like that, or like that, or like that. That's diverging. So we are only able to calculate a sum to infinity for those sequences that are converging, right? It's not possible to calculate a sum to infinity for a divergent series, and you won't do anything on diverging series. If they're all going to be, well, I mean, you could still work with a divergent series in the sense that you could be asked to calculate the sum to so many terms or whatever, but you're not going to be applying it in the sum to infinity aspect. All right, so sum to infinity has its own formula, and I've given it to you over here. So sum to infinity is equal to a over 1 minus r. So this is our sum to infinity. A is our first term, r is our constant ratio, and there is a restriction on this. Okay, so we can only calculate a sum to infinity if r, the common ratio, is a value bigger than, oopsie, I don't know why my pen's done that, bigger than -1, but smaller than 1. Okay, so anything smaller than -1, any r value smaller than -1, any r value greater than 1, it means that the series is diverging and not converging. Okay, so on to the first thing, right? What they could ask us to do is use sigma notation. All right, so they've said to us in here, calculate the sum to infinity for 2 times 10 to the power of 1 minus n, starting with n equals 1, right? So now, because we're working with sigma notation, it's an instruction to sum, so we're going to do sum to infinity, and that is exactly what they want us to calculate in this regard. How are we going to work out what a is? How are we going to work out the value of a, Matrix? What do we always have to do when we're working with sigma notation?
Ma'am, we're going to sub n into the equation we're given there.
Absolutely, Lucidi. Okay, so we need to go and we need to sub in like we always do for sigma notation, right? So if we go and sub n is equal to 1, what's our first term going to end up being? It's going to be 2 times 10 to the power of 1 minus 1, okay? And then our second term is going to be 2 times 10 to the power of 1 minus 2. And our third term would end up being 2 times 10 to the power of 1 minus 3. And of course, we could carry on doing this infinitely, all right, but we're not going to do that, okay? So what is the value of the first term, please, Matrix? You should be getting 2. Okay, 100% it should be 2 because 10 to the power of 0 is 1 and 1 times 2 is 2. And the value of the second term?
One over 5.
I agree. Good job. And the value of the third term?
It's 1 over 50.
It's 1 over 50. All right, and so it keeps going forever and ever and ever. All right, so we know that A, let's write in a different color, we know that A is equal to 2 in this case. How are we going to work out what R is, Matrix?
Look at the first term.
The first term? You sure? To work out R, the common ratio?
Oh, you must get
How would we do that, Tipiso? What would you say? September, what would you do? What would you do, September?
You take the first term divided by the first term, and then you take the third term divided by the second term. That would give you R.
Exactly.
Ratio.
Okay, good. Well done. Okay, so it's a piece. So when you want to work out the value of R, you've got to take the third term and divide it by the second term, or you take the second term and you divide it by the first term. All right, so on your calculators, you can go 1 over 50 divided by 1 over 5, and we should get exactly the same answer if we go 1 over 5 divided by 2. What do we end up with, Matrix?
1 over 10.
1 over 10? Okay, and again, this makes sense to us that R is going to be a number like this because remember, it has to be a value bigger than -1 but smaller than 1 for the series to converge. So, for example, if you had gone and done something else and it ended up being 2 or 3 or whatever, then you know that you've made a mistake, okay, for sum to infinity, because for sum to infinity, R has to be bigger than -1 but smaller than 1. And now it's very easy. We're just going to go and sub into our formula. So in place of our A, we're going to put in 2. In place of our R, we're going to put in the value of R, which in this case is 1 over 10. Now pop that into our calculator. And what do we get as an answer, Matrix? Someone's put it in the chat for us. Okay, it's just Sesutu. Welcome. Don't worry about being late. Okay, Talia, I get the same value as you. I also got 20 over 9. Okay, is that easy enough, Matrix? Does that make sense?
Yeah.
Yes, ma'am.
Are there any questions? No. Okay. Have you had a chance to write that down? We're going to go down to our traffic lights. Okay, thanks to Melo. Good job. Okay, so we're going to go down to our traffic lights, and I'm going to give you guys an opportunity to try this, just subbing into the formula for yourselves. Okay, I'm going to go down. Here we are. Okay, so now at our traffic lights today, what I want you to do is this. Okay, so these are your options for now. Okay, so either you do question 1A and 2B, or you do question 1B and 2B. Okay, so either you've got to do 1A and 2B, or you're going to do 1B and 2B. So there's 2 questions that everybody's going to do. I'm going to put the sum to infinity formula over here for you. And you guys are going to get cracking on that. And if you need us, Katlejo and I are right here for you. Okay, give that a try.
Mm.
Hi, Jason. No, we don't do, Watobe doesn't do maths lit. We only do maths core. Cool. Okay, so Tfile's done, Talia's done, Tumelo's done, Jamie's done. Well done, guys. So we'll just give everybody else another minute or so, and then we'll talk about our answers. Cool, Tatso, well done. Nice. And Lesedi, lovely. Cool, Sekupe. Okay, Clinton. All right, so Clinton, can we start with you? All right. I would like you to please share with me in 1A, what did you get as your sum to infinity?
I got -6 as my answer.
So you got sum to infinity is -6. So that's for 1A, is that right?
Yeah.
Okay, did anybody else get -6 as an answer?
I got 6.
That's all got 6.
Let me check.
Okay, just double check, Clinton. No problem. And what did anybody else get? Did anybody else get -6 as an answer?
Oh, I can see my mistake. Yeah, it's 6. The answer is 6.
That's fine.
Yeah, it was a silly mistake.
That's okay. So did everybody else get 6 as well? Thumbs up, yes, no. Zianda said yes. What about the rest of you? Did you also get 6 as an answer? Talia, yes. Tandal, where to? Thanks for the thumbs up. Valerie, thank you. Okay. All right. Then as far as question 1B is concerned, let's ask somebody else. Tumelo, what did you get as the sum to infinity for B?
Ma'am, I did 1A.
Oh, okay, you didn't do 1B. Okay, so, okay, no problem. Who did 1B? Is there somebody who did 1B who wants to share their answer with us? Oh, cool. Someone's raised their hand. Okay, Michelle, go for it.
Negative 128/3.
Okay, that's what I got as well, Michelle. All right, so Clinton, I saw you had your hand up, and I'm not sure who else had their hand up. I also got negative 128/3 for anybody who tried that one. Okay, good job. All right, well done. And then as far as question 2 is concerned, okay, just hang on, there's people with their hands in the air. Lesedi, do you want to say the answer for number 2? Is that why your hand is in the air?
Ma'am, I got 2.
Oh, for the answer for number 2? Yes,
Yeah,
so did
2.
I. Yeah, me too. I also got 2 as an answer. The rest of you, did you also get sum to infinity as 2 for this one?
Yes, ma'am.
Okay, good job, Tubile. Everybody else, you happy? Thumbs up, thumbs down. Yes, okay, thank you. Thanks, Andile. All right. So fairly straightforward, isn't it? It's just sort of subbing into our formula once we've worked out what the value of A and R is. Okay, so let's go back. Cool beans. Let's go back and go and have a look at the next example. All right, so where were we? Oh, we're over here. Okay, now this is something that we love to ask in sum to infinity. And this particular question has got P's in it. So consider the infinite geometric series P plus P times P plus 1 plus P times P plus 1 squared plus etc. etc. They want us to calculate the values of which, or sorry, the values of P for which the series will converge. Right. Now, without me telling you, is there anybody who knows what we're supposed to do here? Is there anyone who knows straight away what I'm supposed to do for this question? Okay, Siatemba, you've got your hand up. Go for it.
When they say, when they're asking does the series converge or diverge, when a series converges, your R constant difference will always be between -1 and 1. It will not be more or less than those values.
Correct. Okay, so Siatemba's quite right. And Talia, yes, you've got to solve for P in terms of, we've got to solve for R in terms of P. So absolutely. So guys, if you haven't written this down or you weren't sure about this one, make sure that you note this down because they love asking this question. For what values of P will the series converge? And the bit of information that we have to use here, Matrix, is that series will converge when R, the common ratio, is a value greater than -1, but smaller than 1. So we're going to be subbing into a compound inequality, right? We need to work out what the value of R is in terms of P. So remember, we always work out R by saying term 3 divided by term 2, or term 2 divided by term 1. Okay, so we can use either of those in this particular case. All right, so let's say we decide we want to use term 2, and we're going to divide that by term 1. Okay, so because this is factorized, I can say anything divided by itself is 1, and that means that R is equal to P plus 1 in this instance. All right, so now what I need to do, Matrix, is I need to take this P plus 1, and I've got to sub it in over here. All right, so I'm going to take my P plus 1, I sub it in place of my R, And now I have to solve for P. Okay, so when we are working with a compound inequality like this, we want to isolate the P, okay? We want to know what P is greater than or what P is going to be smaller than, because there's going to be a few values for P that will satisfy our equation. So what I've got to do is I've got to isolate P by doing the opposite. So I'm going to take one away from the middle, one away from the left, and one away on the right-hand side. Okay, so that's going to leave me with P on its own, and it's got to be greater than -2 minus 1 minus another 1, or it has to be smaller than 1 minus 1, 0. Okay, so as long as P is a value between 0 and -2, then our series P plus P times P plus 1 plus P times P plus 1 squared will converge. How does that feel? Is that okay? Does it make sense? Are there any questions? Are you guys happy with that? Okay, and then the next part is easy. All right, the next part wants us to calculate the sum to infinity, assuming that it is going to be a converging series. Okay, well, we wouldn't be able to calculate the sum to infinity if it wasn't. All right, so now we've got to calculate sum to infinity. How are we going to do this? So sum to infinity formula is equal to A over 1 minus R. Okay, so our value for A in this case, A is equal to
P.
P. Good, well done. A is equal to P. And R, if you recall, was equal to
P plus 1.
P plus 1. And one of the most common mistakes that high school students make is that they don't use brackets where it is appropriate to do so. Okay, so P plus 1 is a binomial. So when we subtract it from 1, we must remember to put brackets around it so that we subtract the P and the 1. Okay, and not just the P. All right, so this means we're going to end up with P at the top, down at the bottom. We've got 1 minus P minus 1. So that means that, whoopsie daisy, I'm running out of space here. We're going to end up with P over negative P. So therefore, the answer has to be equal to -1. Good, yes. Okay, because anything divided by itself is 1. Yeah. Okay, let me just go up a little bit so that if you want to write that down, you can. Is that okay, everybody?
Yes.
Are we all good? We all
Yes,
fine?
ma'am.
You sure? Anybody
Yes,
got any
ma'am.
questions? Pleasure. No questions? You sure? Okay, see, Atemba, you've got your hand up. Go for it.
Ma'am, in some my teacher told me in some cases, they wouldn't actually give you, like for example, when they say so for a, maybe I'm going ahead here.
No, that's fine. Ask your question.
Okay, they say to you, so determine for sigma notation. Have you done sigma notation yet? Or am I just
Yes.
going a bit here?
No.
Okay.
We did sigma notation last week. Do you remember?
Oh yes. And then they
Yes.
give us sigma notation, for example, for a geometric sequence for sigma notation. They wouldn't they would at times they wouldn't give you the R value, the constant difference. How do you find the sum for that if they don't give you R?
That's fine. Okay, so what I'm going to do, just to answer your question, let me just quickly do something on the side here. Okay, so are we talking about a normal sum to infinity, not necessarily an infinite series?
Talking about a normal series with a.
Okay. All right, no problem. All right, so let's do some sigma notation, and let's say up over here that let's just make something up. So that's 48, and then over here, let's say n is equal to, let's make this a little bit interesting. We'll say 3, and then here I'm going to say 2 times 3 to the n minus 1. Okay, so that is, if we now have to calculate the sum to however many terms. Your question for this was, how would you know how many terms to calculate the sum to? Is that right?
No, my question was, if they were to remove the 3 and the n minus 1, how do you
Yes.
find the sum? Without knowing if it's a quadratic or without knowing is it arithmetic or geometric?
Okay, so you have to sub in. You have to sub in. So the number at the bottom always tells you where you're going to start subbing in. Okay, so you would have to sub in to generate the first 3 terms of the pattern. And then by generating the first 3 terms of the pattern, you would be able to see what your A is and what your D or R is. Okay, so it would be a D in the case of an arithmetic sequence. It would be an R in the case of a geometric sequence. Okay, so if we had a look at this one, all right, when we sub in 3, first of all, our first term in this pattern is going to be 2 times 3 to the power of 3 minus 1. Then our second term is going to be 2 times 3 to the power of 4 minus 1. Then our next term is going to be 2 times 3 to the power of 5 minus 1. So if we just quickly, sorry, because I obviously didn't know that I was going to be doing this. So we 3 squared. So the first term would be 18, right? And then 20 would be 54.
Yes, ma'am.
And then that would be 81 times 2, which is 162, if memory serves me correctly. Okay, so here is this sequence that, or series that's now continuing like this. So it's only by generating the first 3 terms that we can say, well, is 162 minus 54 the same as 54 minus 18? Okay, and the answer to that is a resounding no. Okay, so that means there is no common difference. There's no constant difference. But the only other thing that we've got, if we say 162 divided by 54, what do we get? We get 3. If we say 54 divided by 18, what do we get?
3.
Exactly. We would get 3 as well. Now I want to ask you guys something before we just carry on and actually work this out. Is this a converging geometric series? Can I calculate the sum to infinity here?
No.
No. Can't calculate the sum to infinity because look at the value of R. Okay, R is a value that is greater than 1 in this
Greater than
case.
1.
Exactly. So this is a diverging series. It's not possible for us to calculate a sum to infinity. And indeed, if we were to draw a picture of what this series looked like, so if we had a set of axes, what would end up happening is that our pattern would do that. And it would go on and on and on and on, up and up and up forever and ever and ever. Andile, you asked a question. You want to ask a question? Go for it.
Ma'am, can they make this into a trick question, like, and ask us if can we calculate the sum to this geometric formula? I mean, geometric sequence.
No, Andile, you know, I think that is a common misconception amongst students when they say it's a trick question. So maths is not that mean, okay? They will never ask you. So in other words, it's something like this. If this wasn't a converging geometric series, which it isn't, they would never say to you, go and calculate the sum to infinity. They would never do that to you. All right. So yeah, no, that sort of question you're not going to get. One last question before we carry on and go back to sum to infinity. How would I work out the number of terms in this particular series? Can anyone tell me?
Ma'am,
It's
I think
number at the top minus number at the top plus number at the bottom minus 1.
So the other way around. Okay, so it's the number at the top minus the number at the bottom plus 1. Okay, but you were very close. Okay, so that means in this case, this is going to be the sum to 46. Okay. So September, yes. Ask your question.
I'm sorry, just one more question before we go back to
No problem.
to what we were doing. When for sigma notation, when they give you two sigma notations and say work out the sum of both of them simultaneously, do we do that? Do you guys do that during advanced classes or like normal classes like these?
We did it in the advanced class last week. Yeah, so I did. I gave everybody. I showed them a question where we had done simultaneous equations, a simultaneous solution using sigma notation, and then I also showed them how to subtract one sum from another, where it wasn't actually either arithmetic or geometric. You kind of had to expand things and then see that there was a pattern going on. But yeah, I did that in the advanced class. But I'm going to do exam questions on Thursday, and I'll also do exam questions again on in the second session on Thursday. So yeah, if you guys want to do exam questions, and certainly sort of more difficult exam questions, yeah, then stick around for that second class.
Thank you very much.
It's a pleasure. It's an absolute pleasure. Yes, Emily, ask.
Okay, it's Aisha, but it's okay.
Oh, sorry, it says Emily here, so sorry. I assumed you're strong. Okay, I should go for it.
Yes, ma'am. So with sigma notation, let's your n value is not given. Like what I thought is that you'd only plus one, like say top minus bottom plus one if you weren't given the n value. But I just heard that I can see now that you do it all the time, even if you are given the n value. So just confirming that.
Yeah, absolutely. Okay. So what you will find is that this is kind of like a hack. It's a way of you always being able to get the correct answer. So it's always the number at the top minus the number at the bottom plus one, and it'll work in every single situation for sigma notation, whether you are doing an arithmetic series or whether you're doing a geometric series. Okay. So what they could do if they wanted to is they could, of course, always remove that and then call that something else like m, and then ask you to determine the value of m. All right, in which case, the number of terms in the series is going to be the number at the top, which I've now changed to m, minus the number at the bottom, plus 1. So in terms of m, the number of terms in the series is going to be m minus 2 number of terms. Does that make sense, Aisha?
Yes, ma'am.
Yeah. So I think what happens is that a lot of people have this misconception that the number at the top represents the number of terms in the pattern, which it doesn't. It doesn't necessarily represent that. It depends on where you start subbing in. So if you are dealing with a sigma notation like this one, and again, I'm just going to make something up. So, and then n is equal to 1, and this is 2n plus 3, and let's say it ends at 9, then there will be 9 terms in the pattern. Because 9 minus 1 plus 1 is
9.
But let's take the same pattern, the exact same pattern. It's also starting at 9, but let's say I start subbing in at 2. There's not going to be 9 terms in the pattern. All right, there's going to be 8 terms in the pattern. Okay, so the number at the top minus the number at the bottom plus 1. So that means there will be 8 terms. Okay, so that's why we use that top minus bottom plus 1. Okay, so do not just assume that the number at the top is the number of terms in the pattern, because it isn't. Okay, is that a little bit clearer for everybody?
Yes,
Yes, ma'am.
Cool. All right. Well, thank you so much for all your questions. That was really awesome, and I'm so glad that you have the confidence to ask me, because this has to help you. So you know if you're going to be here, it may as well benefit you. So yeah, if there's anything that you want to ask me, even if it is from 2 lessons ago or something like that, I've really got no problem with that at all. Okay, we're all just here to learn and improve and do the best we can. Okay, Andile, you've also got a question. Go for it. Andile, we can't, well, I can't hear you. I don't know if anybody else can hear you, but you're welcome to ask your question, Andile.
Oh my gosh, sorry. So this whole time I had forgot to unmute. Okay, ma'am.
Don't worry, we've all done that. It's fine. Okay, go for it.
Ma'am, there was this question here last week that we done last week, that the answer, they said that the answer would go close to 0 but not meet 0. Can you please explain that to me again? I forgot to write it down here. There was a case where the answer would go close to 0. I mean, the series would go close to 0 but not reach 0.
Okay, okay, what I'll try and do is I'll see if I can go back and do that after this particular example. Let me do this one first, and then we can certainly go back to that. But what we're basically talking about in a situation like that is, and it's actually got a lot to do with sum to infinity, is if you have got a particular pattern. Okay, so this is now in terms of n, and I don't know, let's call that p of n or whatever the case is, right? And you've got a pattern that is doing that in shape. Okay, so a function that would do that would be something like y equals 1 over 3 to the x. Or if we're working in terms of pn and tn, let's just make that tn. Tn is going to be 1 over 3 to the power of n, right? So when n is 1, we would get a big number. And when n was 2, we'd end up with a smaller number. And when n was 3, we'd end up with an even smaller number. So as n gets bigger and bigger and bigger and bigger and bigger, it gets closer and closer to the x-axis, okay? But that is its asymptote. All right, so it will get closer and closer and closer, but it will never get there. And that's because it does not matter what the value of n is. All right, we can never ever get a negative value. All right, we're always going to get a positive. All right, so and that, I think that's what we were trying to explain to you. Is that right? Does that answer your question?
Yes, ma'am. Thank you so much.
Okay, all right. And that's exactly what's happening with the sum to infinity. We are talking about those kinds of exponential patterns that converge towards a particular value. Okay, so here you can see something that's shaped like that would be converging, and something that was shaped like this would also be converging. Okay, so in other words, it's converging to a value. So when you're calculating the sum to infinity, you're actually calculating the value of the asymptote for that particular function. Does that make sense? But you can't do it if you've got a pattern. You can't do it if you've got a pattern that does that. Because here your asymptote is below. It's not heading towards an asymptote. Okay, it's diverging. All right, so that's actually what we're doing when we're working with a convergent geometric series. It's actually an exponential pattern that is approaching its asymptote, and what you would find is that, you know, the fractions would get so small that it doesn't matter how many more of them you add, you're never ever going to get past a certain value because what you're adding is so minuscule. All right, does that make sense?
Thank you. Yeah,
Pleasure.
Makes sense.
Pleasure. Okay, all right, so let's have a look at like a word problem, right, and how we would solve something like this. Okay, so a convergent, very important for us to read the word convergent geometric series. Let's just highlight that. Convergent geometric series has a second term of 8. Let's put that in a different color. All right, it has a second term of 8. and it has a sum to infinity of 36. The question is asking us to determine the possible constant ratios. And can you see there's an S in brackets afterwards? So in other words, they are implying that there may be more than one answer in this particular situation. All right, so they want us to work out the value of R. They've given us two pieces of information. The first piece of information is that the second term is 8. The second piece of information is that the sum to infinity is 36. We've got to write those two pieces of information as equations. So how would I write the second term of a geometric series is 8? How would I write that? Anybody know?
I'm using it A plus D.
You are very, very close, but A plus D is for arithmetic.
Oh.
Oh, okay, you're very, very close. All right, so A plus D, A plus 2, D3, D4, that is for an arithmetic sequence. For a geometric sequence, we don't write in terms of A's and D's, we write in terms of A's and
A and R.
That's it. Okay, so in other words, let's just stick this on the side over here. Term 1 is always A, irrespective of whether it's arithmetic or geometric. Okay, but if it's geometric, term 2 is AR, and term 3 is going to be AR squared. Okay, so you can see here, we've got AR to the n minus 1. Okay, so our exponent is always 1 less than our term number. All right, so that means that we're going to write has a second term of 8 as AR equals 8. And I don't know if any of you saw, but David went a step further. And in the chat, he said, well, we can make R the subject of the formula by dividing both sides by A. Absolutely. And you know what you could also do, David, if you wanted to, because there'd be more than one way for us to do this. If we wanted, we could make A the subject of the formula. All right. And then it would be equal to 8 divided by R. All right. So there we go, guys. There is equation number 1. How am I going to write the sum to infinity is 36? Does anybody know how I would do that? How would I write the sum to infinity is 36? The sum to infinity. Okay, Siatemba, go for it. Yes.
Please repeat the question again. I didn't hear you.
No problem. I said, how am I going to write the sum to infinity is 36 as an equation?
Oh,
Oopsie,
okay, thank you.
all over the page. Do you know how to do that?
Okay, wouldn't you say 36 equals A over 1 minus R, something like that?
100%. 100%. Okay, and Benedict's put that into the chat as well. Well done. Okay, Benedict and Siatemba, you are quite right. Okay, so we would write the sum to infinity is 36 as A over 1 minus R. That's the sum to infinity matrix is 36. And now we have two equations. All right, equation number 1 and equation number 2, and we're going to have to solve simultaneously. Okay, so solving simultaneously is something that is super, super important for you guys this year. You're not just going to do it in this section, you're going to do it in calculus, you're going to do it in many other sections. So you need to be able to solve simultaneously. Okay, and that means in coordinate geometry as well. We do a lot of simultaneous solutions. So being able to solve simultaneously is a super important skill. All right. Now, they asked us specifically to calculate the value or the values, in this case, of R. So in other words, when we sub into our formula A over 1 minus R equals 36, which one of these two do you think it would be better for us to use? All right. Are we going to rather replace the R and work in terms of A? Or are we going to replace the A and work rather in terms of R? So what should we use? Should we use the pink one or should we use the blue one?
The
Blue.
pink one.
We could use the pink one, but I think it would be better to use the blue one because then our equation only has R's in it. Okay, otherwise it means we first work out A and then we've got to go back and go and sub in and work out what the value of R is. So if we make A the subject of the formula in the first equation and then sub that into the second equation, it's just going to mean that there's a little bit less work for us. But you wouldn't be wrong if you did it the other way. Okay, so now we're going to take A, which is 8 over R, all over 1 minus R, and we've got to make that equal to 36. Okay, now let me just move my traffic light thingy out the way because that's not helping us right now. And now the question is, where do we go from here, Matrix? What do you think we should do?
Ma'am, don't you multiply the 8 over R?
You're on the right track where you said multiply. Okay, if you have a look, everybody, in the chat, David's put something there. He says multiply both sides by 1 minus R. That's quite right. Okay, so what we've got here is we've got a numerator over a denominator equals a numerator over a denominator. Okay, we've essentially got a proportion, right? So what David is suggesting is that we cross multiply. Okay, so we're going to multiply the 8 over R with that invisible 1. And we're going to multiply, let's use a different color, the 1 minus R with the 36. We are cross multiplying. Okay, and then that means we don't have the 1 minus R in the denominator any longer. So 8 over R times 1 is 8 over R. And 36 times 1 minus R means we would end up with 8 over R is equal to, expand our brackets, 36 minus 36 R. Now what are we going to do? We've cross multiplied, we don't have a denominator anymore. Well, actually we do have a denominator. Now we've got a denominator of R. What do you think we should do now, Matrix? Let's highlight this R. How are we going to deal with that? What are we allowed to do?
I think you took out a common factor in the sum.
Okay, when you say a common factor, what do you mean exactly? What would I?
Like you take out 36.
But if I took out 36, then I would end up going back up to that line over there. Okay, so unfortunately in this situation, factorizing is not going to help me. Okay, Andile, what were you going to say? Someone's actually put it in the Benedict, cross multiply. Essentially, yes. Okay, you are cross multiplying again. Yeah, absolutely, absolutely. So whether you multiply, whether you say I'm going to multiply both sides by R, whether I'm going to cross multiply, whether I'm going to multiply each term in the equation by R, in this particular case, all right, it's exactly the same thing. So David, what you're saying here is perfect. Multiply both sides by R, but you have to multiply the entire expression on the right, absolutely, which means that you have to multiply the 36 and the minus 36 by R. Okay, so that means we now end up with 8 equals 36R minus 36R squared. Okay, is everybody happy with that? Let me move this out the way so that we've got space to write. I'm going to move that one out the way as well. Okay, now what do you think we should do, Matrix? What would you do from here?
You
Put it in standard form. Good. Exactly. Put it in standard form. So if I bring these two terms over to the left-hand side, I would end up, and I could bring everything over to the right if I wanted to, it doesn't matter. But yes, quite right, David. Bring it over to, everything over to one side. Minus 36r plus 8. And I've got to make it equal to 0. Okay, 100%. So everything goes over to one side because this is quadratic. And now what am I going to do, Matrix? What do you think we should do? David's made a suggestion. That's quite right. Anybody else?
Sub it into the quadratic equation.
Yes.
Exactly, Andile. Okay, Siatemba, is that what you were going to say as well?
Yeah, I was going to say, I think factorize it. I was going to say factorize.
You could factorize it if you wanted to, absolutely. All right, so the mark that you get, Matrix, for factorizing is the same mark that you get for using the quadratic formula. If you use the quadratic formula, you must show that you subbed in. Okay, you must show that you subbed in. If you're working with factors, do not leave off the equals 0 at the end, or they're going to mark you down on that. Okay, so just to make life easier for ourselves, we're going to use the quadratic formula. So I'm going to write r equals, not x equals, r equals negative b. So that will end up being, oopsie, not negative, it will end up being positive. Let me just get rid of that. So negative b, so that will be positive 36 plus minus b squared. So negative 36 squared. Very important that you put the b inside brackets. Minus 4ac. Okay, and that is all going to be over 2a. So now, Matrix, let's just get rid of these, which were left over from the other question. We're going to end up with two solutions for r. Either r is something or r is something else. So I'll give you a minute or so to be able to work that out, and then you can tell me what you're getting.
Ma'am, the first R is 3.
The first r is 3.
Yes.
Okay, all right. And what's the second one? Are you sure it's 3? I didn't get 3, but I could be wrong.
Ma'am,
I got
Also-
2 with 3.
sorry, I just network and I did not hear the previous example.
Got 2
so-
with 3.
That's fine, never mind. Okay, we all make mistakes, no big deal. Okay, so yes, Talia, I also got 2 over 3 and 1 over 3. Mashe, how did you get 1,19? David, I got the same answers as you guys. So I got that. Mashe, do you know, can you tell us what you've got on your calculator? Maybe you pressed, just go back and check everything carefully, make sure that you entered it 100% perfect. Yes, Tumelo, I agree. I agree. Does this make sense to you, Matrix? Are you happy with it?
When I
Yes.
transposed the
Yes,
8
ma'am.
to the standard form, I got negative 8, and yeah, I see on the screen it says positive 8.
Oh, okay. But you know what you can do as well, Meshe, which is also not a problem. Okay, so in other words, when we're working from here, if you want to move the 8 over to the right-hand side, then you would end up with 0 equals minus 36r squared, all right, plus 36r minus 8. There's nothing wrong with that. It'll give you the same answers. So maybe did you maybe just get one of these signs wrong here, Mashe?
I think so. I'll check now.
Okay, all right. Okay, but yeah, whether you moved everything, whether you transposed it all over to the left or to the right, as long as your signs are correct, you will get the same answers. Okay. All right, well, we've only got just a couple of minutes left. Let's see what we can do. Yes, Tandalwetu. Yes, Tumelo. Well done. Yes, David, 100%. I think, let me give you a choice here. Either you can do number 4 or you can do number 6. We're in a little bit of a rush because we've only got 5 minutes. But yeah, give either one of them a try and then we'll just talk about what the answers are now. And then, yeah, unfortunately, that's our time up. Sure, go so fast.
While everybody's doing the equations, ma'am, can you please explain how you solve them simultaneously?
With pleasure. Where did I lose you?
Ma'am, I wasn't here when you were solving simultaneously.
Oh, did you see me, Tatsu, did you see me make the 2 equations?
Yes, ma'am, I saw that.
Okay, all right. So in other words, the one equation, everybody else just ignore me and you carry on with either question 4 or question 6. So you saw me say the second term, sorry, not squared, that would be the third term. The second term is 8. And then you also saw me say that the sum to infinity is 36. So there, Tatso, is equation number 1. Here is equation number 2. Because the question wanted us to solve R, I made the suggestion that when you rearrange this equation that I've highlighted in purple, make A the subject of the formula. Okay, because if you make A the subject of the formula, you're then going to sub in here and you'll get rid of that A over there, and then you've got everything in terms of R. Okay, so it just helps you to work a little bit smarter. So this is going to be 8 over, divide both sides by R. Okay, and now what we want to do is we want to go and sub in. So we're going to take that 8 over R is A, and we're going to sub it in over here. Okay, so now I've got, whoopsie, let me just get rid of the highlighter. We want to go back to black. Okay, so we've got 8 over R, which is A, all over 1, whoopsie, that is not a 1, all over 1 minus R is 36. Okay, so what we need to do now is we need to get rid of this 1 minus R in the denominator. Right, so this is why different people were saying we're going to cross multiply. So what we're going to do is we're going to multiply this 1 minus R in the denominator with that, because that's in the numerator. Okay, and then there's an invisible 1 in the denominator over here, and that invisible 1 is being cross multiplied with this 8 minus R, like so. Okay, so that means that we end up with 8 over R is equal to 36 times 1 minus R. Then when we remove our brackets, we're going to end up with 36 minus 36R. Okay, and Jabula, you're done. We're going to talk about the answers right now before we go. And now you've still got this pesky R in the denominator hanging around. So what you can do from here is multiply each term in the equation by R. So that gives you 8 equals 36R minus 36R squared. And then from there, get it into standard form. Right, and then you would go into your quadratic formula, make sure that you've shown that you've subbed into the quadratic formula, and then you would write your values for R. Okay.
Thank you.
All right, awesome. No problem. All right, so everybody's done. Okay, so let me ask you, who would like a chance to chat? Or where to? Are you feeling brave? Do you want to tell us what you got for, or mind you, let me ask you, or where to, did you do number 4 or number 6?
I'm still busy with number 4, ma'am.
Oh, you're still busy with number 4. Okay. well, we unfortunately don't have an awful lot of time. What you guys should have done for question number 4 is working at the values of x for which the series would converge. You should have worked out that r was equal to 2x plus 1. So you would have taken 2x plus 1 and you would have made it greater than -1 or smaller than 1. Take 1 away from all of these. So this is -2. And then over here, this is going to be 0. And now you've got to divide through by 2. So x has to be greater than -1, but smaller than 0. That should have been your answer for 4A.
Yes, ma'am.
Ma'am.
And then, yes, is there a question?
Yeah, when the inequality signs supposed to change direction since
Good
divided?
question. When do inequality signs change direction?
When you divide or multiply.
No. When you divide or multiply by negative.
Oh.
Only when it's negative. So in other words, if I make a statement, let's say I say 2 is smaller than 6. That's a true statement, isn't it? Okay. But if I divide this side by -2 and I divide that side by -2 and I don't change my sign around, I am saying that -1 is smaller than -3. So now this statement over here that I'm highlighting in pink, that is not true. Okay, and that's why the inequality sign has to swing around. Okay, because -1 is greater than -3. Okay, and the same thing would happen as if you multiplied. So again, if you had something like 5 is smaller than 10, if I multiply this by -3 and I multiply that one by -3 and I say -15 is smaller than -30, then again, I've made a statement that is not true. This statement over here that I'm highlighting in light purple is not true. My sign has to swing around. Okay, because -15 is bigger than -30. So it's only when you multiply or divide, yes, by a number that is negative, not just if you're dividing. If you divide by a positive number, the signs don't switch around. Okay, the other thing that you need to be aware of, sorry, we're just like really rushing this over here, is let's say you had something like this. Let's say you had -2x plus 1, and that was greater than -1 and smaller than 1. So now you take your ones away. So now you've got -2 is greater than -2x, and then over here you've got 0. Now you're going to divide through by -2. Just move this up. So you've got the x over here, and now you're switching your signs around. -2 divided by -2 is 1. And now you say I'm dividing by a negative, so I'm going to switch my sign around. And 1 divided by -2 is -1 over 2. If you leave your answer like this, you will also be penalized. All right, you can't write it like that. The smaller number, the -1 over 2, has to be on the left-hand side. All right, so you're obliged to write it like this. X is greater than -1 over 2, but smaller than 1. Okay. Okay. Katleho, what did you get as your answers for the harder question? Did you work that one out?
Yes.
Okay, lovely. Do you want to share that with our students?
Okay. I ended up with r equals -5/3 or r equals 2/3. I disregarded the -5/3.
Absolutely, because the answer is?
Yes.
Because -5/3 is smaller than -1.
Smaller than -1.
Yes.
Yes.
Absolutely.
Then I substituted it to work out a. And I found that a is -1. I don't know if anyone else did it. I may have made a mistake. And eventually I found Tn to be -2/3 to the exponent of n-1.
Okay.
No, the negative is outside because that's the a. It's outside the bracket, not
Sorry.
inside.
Okay. So like that.
Yes.
Okay.
I'm not sure if anyone else tried it.
Did anybody else
I
get
was
that?
rushing.
Did anybody else tried it? No. Okay, no one.
Okay,
Jamie
got-
says she got the same answers.
Okay.
Okay, all right. Unfortunately, we're out of time now. Njabula, you said you didn't get the same answers. What we can always do is, if you want to, I can start the next lesson on Thursday with this particular question, and we can just work through it quickly. Okay, would that work, Njabula? How does everybody else feel about that? And then, Jamie, we can give you a different question to do because you've already done this one.
Yes, please, ma'am.
Okay, all right, awesome. Okay, guys, well, unfortunately, that's our time up. It goes by way too